Hello everyone, welcome back to Day One Dev. Today I'm going to talk about tokenization technique in natural language processing. So before we jump on the detailed topic, uh, please subscribe to Day One Dev if you are not haven't subscribed yet. So I'm bringing in a lot of machine learning and new initiatives which I'm building as part of my work. And you also can connect with me on my LinkedIn. I'm sharing here my LinkedIn ID and as well as my YouTube channels. Right. So let's not to waste our time. Let's jump on our tokenization technique in natural language processing. So in natural language processing, there are a few ways of doing a tokenization. So for example, if you have a pretty big paragraph and multiple paragraphs, it can be, and where you can do sentence tokenization. Then from a sentence, you can create a word tokenization. From a words, you can do a sub tokenization. So you can see here, which I called out. From a word or sub words, you can create a character tokenization. So in today, I'm going to talk about these two examples I'm going to share with you in this using various techniques, which is one of them using an open AI uh, tokenization, as well as another one is an hacking faces. And the third one, I'm going to talk about NLTK, natural language tokenization part. So there are three scenarios I'm going to talk about here, and it's pretty simple code. It's hardly one or two lines of a code for tokenization, send word tokenization, and it's going to be, you might love it, which if you are doing any project, this will bring you various perspective. All right. So let's start with our part, which moving on. So let's, as you know, starting is always importing a few libraries, which I'm also going to talk this about tick token, NLTK, which I'm using. Uh, the third one, I was using a transformer. I think somehow I did not import it. Maybe I should put it as a transformer. The reason I might have not done is uh, as part of my previous download, I might have downloaded. So that was might be the reason you don't see it here, uh, transformers. So that might be the reason I'm not downloading it, because it might be in my internal repository and I don't need this token. So let's me restart everything, kernel. So that's going to be easier for you to see this. All right. So let's, as I said, use these three techniques, which is the OpenAI, tick token, NLTK, and transformer. We're going to talk about these three. And as I said previously, it was an auto time. It's just to call out that time, how long it took that object or a code block to run it. So this is a variable I'm using it, which I uh, called out here. So you can see there's a sentence, hello, I'm learning natural language processing. Tokenization is my first step in NLP tasks if you're doing anything. So either you're doing a paragraph to sentences or sentence to a words. So just I picked there are two sentences you can see here. I have it. We're going to talk about that. And there are, for every sentence has a few words. All right. Let's start with our first OpenAI tick token. There's a GitHub link also I provided you for this OpenAI one. So if you see here, I did import it and I'm just printing my token, whatever I have my text. Then I'm just encoding, I'm using a tick token to encode for a model, which I'm using a GPT 3.5 Turbo. And you can see just I'm encoding it. And rest of the stuff is just I'm printing the token size, the number of tokens I got it, and just looping in through the entire text, the number of tokens, and I'm decoding that to put it back my all the tokens into a single, the way I extracted. So if you call this out, the encoding and decoding, which I'm going to do a separate topic, what is encoding and decoding. So for now, just this is just putting back all the token words into a single sentence. So you can see here, this is my original text, and extracted as a 23 tokens. You can see here, hello, exclamation, I have it as a single word if you say it, but tick token extracted this as a two separate tokens, it made it, right? Similarly, you can see that I am also, if you see here, this one is a single word, but it's split as a two tokens here. And similarly, you can see that the way it has been extracted and it became 23 tokens. And when I put it back as a decoded text, it came back as is. Okay. Now, the second transformer, I'm using it, and also you can see here it took 115 milliseconds. All right. So we're going to do this other stuff, just logic I'm talking about, not an import. So similarly, here I did using NLTK. You can see here where you can the library which I'm been called out and the documentation, everything. All right. So in NLTK, I'm going to talk about two different tokenizations. One is a word, the other one is sentence. So if you see here in a word, when I did the tokenization, it became a 21. Not if we go back to my the tick token, it considered as a 23 tokens, right? So if you want to compare, you can do that. So you can see here pretty much hello exclamation, it became pretty close, but there is a few words which are not considered as part of this one. So this here, NLP, it made as a two tokens, but here it considered as an one token. So there are a few things you can see that the small differences. So that was a reason if you look at the tick token, ChatGPT is very smart compared to other tokenizations because it knows all the word stuff. And now on NLTK, I'm going to talk about a sentence tokenization, which I go back I talked about it. So I can see here I have a same sentence I provided. It's nothing is changed, but somehow it considers hello as in a sentence exclamation. Then after that, it considers in a one sentence token. The other one is an another sentence. So it considers three tokens. All right. Now, the third scenario, I'm going to talk about Hugging Faces tokenizer, which is used as a transformer as part of an auto tokenizer. So in this, I'm using two different models. One using OpenAI ChatGPT 2 model, and the second one I'm using a Google BERT model. Okay. So when I'm using it, OpenAI ChatGPT, if you see that it's pretty close to tick token, which was 23 tokens it made it. So the another example you can see here, NLP, it's became as a same thing, NLP. It's a two words. It's made it. It's not a single word. It didn't made it as an NLTK, right? So you can see that it still became as a 23 characters. Nothing is changed, whether you use a tick token or using a Hugging Faces transformer within a GP2 model. But just on a call out, I'm using only two sentences here, or maybe you can call it the three sentences. But based on the three sentences, I do not consider or I do not want to make this as a scenario where I decode that as an uh, I do not want to decode and I do not want to call out that as an it's a simple form we are making it. All right. So now let's go to a Google BERT model. If I see it, there's a Hugging Faces documentation I provided here. And but if you use a Google, if you see this, it became as a 27 characters for the same text. I did not modify any text. That's the same text I'm calling out in every place. And it considered as a 27 characters. For example, it considered the CLS this year. There's a one first token it considered. And similarly, the last it considered as a SCP. It's a separate, right? So similarly, you can see here in a tokenization, it created a sub token of a tokenization. And similarly, in LP, it became a sub token instead of making N or LP the way Tick token was doing it. But Google one was making sub tokens here. So it depends on your problem. You can use the various tokenization technique. But as I called out here, some challenges, especially if you are doing it. If you're not using a tokenization, depends on your problem. Uh, Definitely does not understand the rock star versus a rock star. It's easier. So, and there's always ambiguity in the punctuation and contradictions. You can see that which I called out here too. on especially IAM, which I was using it. So you can see here, I is considered as apostrophe, the single quote, and M it considers a three words. But if you go back to the bit token, if you remembered, oh sorry, tick token, if you remembered, it considers I as a one word or one token. The second one is a single quote, and M is considered as in a second token. So it varies how based on how which and what problem you're solving it. So I hope you make a decision when you're picking up based on your uh, uh, tokens, how you're gonna use it, but it's always best way based on your problem. You figure it out which tokenization technique is a best suits for your problem. All right. I hope I talked about I explained you about frameworks is available, and also there are more frameworks available from TensorFlow and PyTorch. You can explore that, but just I wanna call out as an ChatGPT one and Transformer. These are highly used in the market. All right. I hope given you valuable information. Please subscribe to Day One Dev, and I'll see you in the next video.